While on the internet, you may have seen videos that show houses outlined in RGB lights and wondered how exactly do they do that. This video aims to cover some of the details on how you can accomplish this. It will not provide you a step-by-step guide, but it will get you in the right direction. You will need to consult with your specific vendor to determine the specifics of the controllers, protocols, types of lights that need to be used, and their requirements. First, a little bit of terminology. We use the term pixels to refer to individually controlled lights. That is, one light that can be directly controlled. Now, you may have also heard the term intelligent or smart. Again, those also refer to what we'll be talking about as pixels. Now, there are also basic or dumb RGB, and that is where you control a single line or length of RGB lights as one color. So for example, you may have 10 lights on a string and they will all turn red at the same time. You cannot control each individual one directly. Those will be referred to as dumb RGB. First, let's just take a look at two different kinds of ways to do outlining with RGB. The first is to do it in segments, and this uses generally dumb RGB modules or strip, and allows you to control sections. So for example, we might be able to control just this top part as one whole part, but not make it individually controlled. So let's look at some videos first that show that. This house has individually controlled sections. You can see that most of the major sections of the house are outlined, and you can see there where each individual section is controlled. So for example, this section right here is one section, this section is another, this section is another, this section is another. But the lights within that section cannot be controlled. So it still has the appearance of a lot of control, but without the need to control each individual light within that segment. So this has some advantages. The first main advantage is it's a lot easier to sequence. So instead of controlling, let's say, across this length right here under these monsters, let's say that normally would be 75 channels for that small area, and you would have to sequence for each one of those channels. Instead, you might have just 3 channels, or in this case, this customer has 6 channels for this entire length of RGB. So, this tends to be a less complex and simpler method to sequence. Now, of course, you can't directly control each individual light, so that does limit you to certain types of animations. Now, here's another example. Here's another house. This is a little simpler, and you can see that each segment, so for example, under the soffits here, each segment is individually controlled, but there are enough segments in this customer's display to allow the customer to do things, for example, like here, they're doing floodlights in combination with segments underneath the soffits of basic or dumb RGB. Now, those are simple methods. Now you have here an example of a much more complex method. Here you can see each individual light is being controlled. It allows a lot of flexibility and some fairly unique functions. Now, every single one of these lights, so you may be able to actually make out in this particular case that they're individual lights. Every single light requires 3 channels. And this can add up to thousands and thousands of channels. Okay, so now that we have the basics of the 2 different types of ways of lighting our house, let's look at the ways in which you could use different types of lights to light them. So there are basically 2 different kinds of lighting. There is strip lighting, and strip lighting comes in a length or ribbon, and this ribbon has individual lights. Now, usually within each individual segment, if you have basic or dumb RGB, the entire strip will be attached to a controller and controlled all at once. Now, for RGB pixels, each individual section, usually about 3 inches long, can be directly controlled, and each section will have a chip. Now, this video here is showing an individual section but this section is basic RGB and there is no chip in here, so this is not individually controllable. Now, that's one method. There are other methods too. Here are nodes. We call these nodes. These are 8mm or sometimes 12mm nodes. These nodes look very similar to mini lights that you may have used in the past. These can be purchased either in basic or dumb, or they can be purchased in individually controlled pixels or intelligent. Now, these generally are not the best option for outlining your house, and the reason is that this LED has to be pointing directly at the customer or the viewer to be optimally viewed. And it can get complex to build an infrastructure necessary to support and aim these in the correct direction. So often, nodes are less than ideal for using on an outline. Another common method is to use modules. Modules are simply the same equivalent things that are within strip. They contain 3 of these LEDs for each section. The advantage to these is that they're easy to move around different directions, so if you have to make lots of different turns, unlike strip, which can be very complex and hard to cut and maneuver, you can do that very easily because each individual module is wired one to another, allowing you to change the spacing and to move around different areas. Alright, so those are the different kinds of lights that can be used. So there are basic, like these shown here, or they have the exact same kinds of modules and strip in intelligent or pixels. One of the other issues that we need to look at when we're designing any display is how it's going to be laid out onto the house. Now, this is where your vendor-specific information will be required. In this case, we have a sample picture here showing a regular house, and we're going to go through the issues that are involved in the questions that I would need to ask about outlining. The first issue, and probably one of the larger and more complex issues to deal with, is power. Now, you can check our blog for other articles on limits within power, but most vendors will specify that there are limits to the length of individual modules that you can string together in a serial connection. So, you can't, for example, just take the entire length here, all the way up here. Oops, let's just see here. And go all the way down. Your particular vendor may not allow a length of cable that long. You cannot run them in one contiguous length. You need to address power issues. So, you may, in this particular case, be required to break them into sections. For example, you may have to run a section, put power here, then run another section, put power, run another section, put power, and then run another section. Now, how do you know how long those can be? You'll need to talk with your vendor. Your vendor should list the maximum length that can be run. For most strip, the length is a maximum of 15 to 20 feet. That varies. Now, that doesn't mean that people do not run them over, but as you run them over, you will run into problems with either loss of signal, or you'll run into issues where the power drops. So, just like a water hose, if you're running water through a really long hose, as the hose length lengthens, the pressure of the water coming out at the other end reduces. So the same thing applies in electricity. If you power at the end here, or at the beginning here, and you go all the way to the top, by the time you get to the top, each one of the lights will have used power, and so that the lights at the top may be starved for power. And that can either cause their computer chips to not function correctly, and thus act erratically, or they may actually be dimmer. So for example, you could start out with 12 volts at the beginning, and end up with 7 volts at the end. So now that we've talked about the variety of different issues with power, let's go ahead and start laying one out. We're going to go ahead and start off laying it out using basic or dumb RGB. What I'm going to do here is go ahead and figure out how much control I need and where I need to control them. Now, as you add more controllers, your complexity obviously increases. Now with basic or dumb RGB, even if you add additional sections, usually there's not that much more complexity added. So for example, let's say that we have this run here. And let's say that this run is a length of 10 feet. First, we would need to confirm that we could run this contiguous length of modules or strip in 10 feet before we have to re-inject power. And in this case, what we would do then is we would mount a controller here, and that controller would then feed the entire length of basic RGB all the way up to here. Now, we then would come down, if we were going to do the other side, we would come down here, and we would then put another controller here. Now, we could go with one controller for the whole length, but then we would lose the ability to control one section going up, stopping, and one section going up and stopping. So now we can control each half of this gable roof. Now, let's go ahead and do the remainder. So for example, we may wish to control this section over the front door as one total section, so we'll just run one entire length. Again, assuming that there are no power limits, we'll put a controller here. Now, where you put your controllers, you'll need to be thinking about that, because when you're finished, you're going to need to wire signal and power to each one of these controllers. Alright, so next we'll come up this roof, and we'll do that as one controller, and we'll come down this section of the roof. And in this case, we may say, okay, well, we'll put a controller here, and we'll put a controller here. But let's say that this length is too long. We've determined that there's not enough power that can be pushed through the entire length of RGB strip or modules up to the top. So maybe we need to break it. So what we may do is end up going this section, even though it's one section, and then putting another controller here and continuing on. Alright? And so we'll do some more here, and some more here. And again, we just drop in controllers. Now here, it might actually be advantageous to put the controller on this side and this side and go down from here, because we already have a controller here, centralizing our power and controllers. Now that we have that set up, we would need to run the data signal. So you always want to try to run your data signal from one to another. So purple is going to represent my data signal. So let's say we come out this door, or this window, we go up, and let's say we run it along here, over here, up along here, over to this controller, here, and then finally down. Now that doesn't include additional controllers you may have throughout your display. Okay, so that shows you the basics of setting up a basic RGB segmented design. Now, what are we looking at for in terms of channels? For channels here in this design, we would have 3 for this one, 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 and 3 for this one. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 segments. So we only have 24 channels to control for all the segments. Now again, we'll only be able to control each segment, not individual parts within each segment, as we can with intelligent RGB. But this is fairly low cost. So for example, here you could purchase controllers that are as little as $9 for each one of these, and controller or RGB modules that might just be 50 cents to $1, depending on what type, for each individual section. Pixels follow the same physical issues. So in other words, you still need to run them along areas, and they still have the same issues in terms of power. But in terms of signal and a few other issues, they're a little bit more complex. So let's say that we want to run some modules or strip up this section, and we want to do them with pixels. Well, because we want to do them with pixels, we want to control each section along here and here individually within that section. Well, let's say that there's not a limitation here. We can go ahead and run down. So we can put one controller here. So let's put a, this is a pixel-based controller. And we simply run the signal up and then continue down. We will be able to then control every single little segment within here individually. Now, that's a good thing and that's a bad thing. Of course, with intelligent pixels, you have to control all those channels. So, a length of cable or a length of ribbon or modules can add up quite quickly. For example, it is not uncommon for a 15-foot section. So let's just assume this is a 15-foot section, which is about 5 meters. And that could be as many as 150 channels for controlling that entire segment. So there can be quite a few channels involved. So you can imagine, let's say that there are 150 here, and let's say that there are 250 here, and there are 700 here, and there's 200 here. This means that you'll be able to directly control more sections, but at the cost of more complexity of sequencing. Now, let's go ahead and finish out this diagram if we were using pixels. So we'll go ahead, run pixels up here, and let's say that even though we would like to just go ahead and just roll this around and continue on down as one continuous string, often there are power limits, so we're going to stop, and we're going to go down here, and again, let's say that that's as long as we can go, and we'll start over again here. So in this particular case, we would have a pixel controller here, a pixel controller here, and let's say a pixel controller here to hold this section here. Alright, and so we'll do some more sections here. We'll go up, and then down, and then up this section. So again, what we may have here is a pixel controller on this section here going down, and a pixel controller, let's say, over here, and we've got one for here. Alright, so we've got all our controllers. Now, some of the other issues involved with pixel-based controllers. Now, you can't run long distances between where your controller is and where your pixels actually start. This varies by protocol and controller manufacturer, but a good rule of thumb is less than 10 feet. So for example, let's say that I have a controller, and there are two different kinds of controllers. There's centralized and decentralized. A centralized controller often is good for Megatree, where you have a huge number of pixels all in one location. Well, as you can see here, we have a very decentralized system. We have to have a decentralized system because there are power limits within the cables or the strip. And so we have to put these controllers all over the house. So let's say, for example, we had a pixel-based controller that was a large 16 output unit. We have it right here. If we had it right here, getting the cable all the way over to here and all the way over to here would be well beyond a typical range of about 10 feet. That means that the signal, which is fairly low power, will not be able to reach all the way up here and then get to here and then start repeating. So, be wary of central controllers that are large 16 or 8 channel outputs. They are great for Megatrees, but not always great for distributed systems. Now, that said, there are some controllers that do feature what are called phantom pixels, where you can put in pixels that basically don't light up. They're just there to repeat. So the signal comes out, there's one right there, one right there, one right there, one right there. So the signal goes from here to the controller, here, to here, to here, to here, where it actually starts operating. So, in that case, these pixels are not actually there for functioning in terms of output, but just there for phantom output. So, that varies. That feature is most often available on large centralized controllers, but we generally recommend decentralized controllers where you're putting the controller near to where your pixels are located for outlining houses. So, that concludes a very basic overview of the issues involved with outlining your house in RGB. We hope this has been helpful, and if you have any questions, just post a response on our blog.